Hello everyone, we're doing section 2.4 for pre-calc. It's dealing with adding, subtracting, and multiplying and dividing complex numbers. Complex numbers are any numbers that can be written in this format. So when you add them, it's kind of like treating I like a variable. Now it's not. Pi is not a variable, it's a number. I is not a variable, it's a number. But if you had 3 pi plus 5 pi, that's what I'm saying. You could treat it like a variable. You get 8 pi. Okay? Treat it like a variable insofar as you're going to add like terms. You're adding, so the parentheses really aren't necessary. 1 plus 2i plus 3 minus 5i. You're just adding like terms. 1 and 3 make 4 plus 5 minus 5i. 2i minus 5i is minus 3i. So your answer, you could leave it like that, or you could write 4 minus 3i. Okay? If you're subtracting, a little bit trickier, but nothing with huge obstacles. You're going to distribute this subtraction in, and then combine like terms. So minus 3 plus 3i. So adding and subtracting, not a big deal. Powers of I. Before I go to multiplying, I just want to remind you guys a little bit about this. I is the square root of -1. I squared, by its definition, is -1. I cubed, think of it as, I squared times I. I squared is -1 times I. Don't bother evaluating the I, it's just -I. I to the fourth is I squared times I squared, which is -1 times -1, so I to the fourth is 1. Now, this, I'm going to break things up into terms of I to the fourth, because I to the fourth is just worth 1. So that's I times I to the fourth. So that's I times 1, which is I. I to the sixth, I squared times I to the fourth. I squared is -1 times 1, which is -1. I to the seventh is I cubed times I to the fourth. That's -1. I cubed, I already know, is -I times 1. So it's -I. Same thing. I to the eighth is I to the fourth, times I to the fourth, which is 1 times 1, which is 1. So this is going to be the same as this, is going to be the same as this. So this is I squared, which is -1. This is going to be I cubed, which is -I, and this is going to be I to the fourth, which is 1. This pattern continues forever. Okay, so just make you aware of that. This is something that you're also going to see in future math classes you take. This same pattern is going to creep in. So here goes. When you're multiplying and the stuff inside is positive, you're allowed to bring this together when you're multiplying radicals. Right? When the stuff inside is negative, not so much. So let me show you what you're supposed to do, and then I'll show you why bringing them together doesn't work. When you have a negative inside an even root, inside a square root, you're supposed to pop that negative out as I. So it's I square root of 2 times I square root of 18. So that's I times the square root of 2 times the square root of 18, just rearranging stuff. So that becomes I squared times the square root of 36. I squared from previous work, you guys know, is -1 times 6, so -6 would be your answer. You know that's the answer. You did it the long way and you got -6. Here, if you do a shortcut and bring them together, -2 times -18, you get the square root of 36, which is 6. It's not. That's not the answer. The answer is -6. You can only bring radicals together like that when the stuff inside is positive. When the stuff inside is negative, you have to deal with it first. You have to deal with pulling out anything that's inside. So this one, need to be a little bit careful. If I multiply this out, I get -8 times -8. The i's pop out. I square root of 8 times I square root of 8 And you get I squared times 8, which is negative 1 times 8, which is negative 8. Okay? Now this is different. Now we need to split this here. Negative 8 squared is not the same as the square root of negative 8 squared. This is negative 8. You just saw it. If I do this out the long way, that becomes the square root of 64, which is 8. Okay? So it does matter where the square goes. When in doubt, just do the stuff the long way. Like I did this the long way. This would be negative 8 times negative 8, which is square root of 64. Then I did the square root. So when in doubt, don't do any shortcuts. Okay. So here, multiplying. So that would be, just going to FOIL this, guys. FOIL. That's all we're doing. So that would be 6 plus 21i minus 10i plus 35i squared. And yes, you have to cash in I squared. So you combine like terms. 6 plus, what would that be, 11i plus 35 times negative 1. So that becomes minus 35 and 6. So that would be minus 29 plus 11i. And remember, it has to be written in the a plus bi format. So the piece without the I comes first. This, you're just going to multiply this in. So that would be 15i minus 10i squared. So 15i minus 10 times negative 1. So that becomes plus 10. So 10 plus 15i. This, remember, you can't distribute over adding and subtracting. So it's 3 minus 5i times 3 minus 5i. And you FOIL it. Or you remember the shortcut. When you have a perfect square, square the first thing. Multiply these together and double it. Square the last thing. So it'd be plus 25i squared. Okay, so that becomes negative 1. So it'd be negative 25 and 9. So it's at negative 16 minus 30i. Whoops, 2 i's, 2 dots. There we go, it's a special I. Okay, whoops, missed it. Come on. Alright, that's all that's on that page. This one. Difference of square pattern in the conjugates. Okay, difference of square pattern. When they're identical, but one's a plus, one's a minus, remember that the middle is always going to cancel out. 9x squared plus 15x minus 15x minus 25. These will always cancel. So really, you just square the first thing minus square the last thing. Excuse my cough. So when you've got something like this one, the shortcut, just square the first thing, square minus square the second thing, and you're done. So when you see this, you could FOIL it out, but the middle's always going to cancel, so why bother doing it? So square the first thing, 9 minus square the second thing, 25i squared, which is 9 minus 25 times negative 1. So 9 minus a negative 25, which turns into plus, so your answer is 34. All right? Notice that when you multiply complex conjugates, a plus bi times a minus bi, the I completely disappears, and you're left with just a number. Okay? That's an important fact to keep track of. So this pattern would go 4 minus 9i squared. That's 4 minus 9 times negative 1. So that's 4 minus negative 9, or 4 plus 9, which is 13. Okay, you need that in order to divide I. All right? You're going to multiply by its conjugate. Its conjugate would be 2 minus 3i over 2 minus 3i. Now, I've talked about this earlier in the year. The top is the same as the bottom, so you're really just multiplying by 1. I haven't changed its value. The top is 2 minus 3i. The bottom is that difference of square pattern. Square the first thing, minus 9i squared. So you have 2 minus 3i over 4 minus a negative 9, so that goes plus, so you get 13 on the bottom. Because it's a complex number, it has to be written in a plus bi form, so that means you have to split this into 2 over 13 minus 3i over 13. You have to split it into two separate parts. Multiply by the conjugate, 3 plus 5i, 3 plus 5i. The top is pretty straightforward, 3 plus 5i. The bottom, that would be 9 minus 25i squared, so that's 9 plus 25, going a little bit faster, so it's 34, and now you have to split it. 3 over 34 plus 5i over 34. Alright? When there's a number other than 1 on the top, no big deal. The conjugate is still the conjugate. The conjugate is unaffected by whatever's on top. The 5 is going to distribute through, so it'd be 30 plus 20i over 36 minus 16i squared, so that would be 36 plus 16, so it's at 4652, so 52 is the denominator, 30 over 52 plus 20i over 52. Yeah, you got to reduce stuff. So I believe there's a 2 that's in common here, so that would be 15 over 26 plus, so that'd be 10i over 26. Okay? So that's how you would multiply divide complex numbers. All right, when you also have an I on top, how you go about it is unaffected. You're still going to multiply by the conjugate. 3 minus I, 3 minus I. Take care of business on top. This distributes to both things. So 6i minus 2i squared. If you want, you can just continue with the top and get the top all nice and polished up. 6i minus, a negative 2, because that becomes negative. That's a negative 1, so negative 2, so this goes plus. So you turn it around, 2 plus 6i. And you know you're going to have to split it, so if you want, you can split it right away. This bottom becomes 9 minus I squared, so there'd be 9 minus negative 1, or plus 1, so it's 10. So you split it over 10, and then you reduce it. 1/5 plus 3i over 5. That's a final answer. When you've got one like this is about as bad as it gets. We'll see what this next one is down here. Oh, that's actually easier. This last one. Okay. 2 minus 3i, top and bottom. The bottom, that's in this case going to be the easy part. So 4 minus 9i squared. So that would be 4 minus a negative 9. So the bottom, you know, is going to be 13. The top, you're going to have to FOIL it out. There's no other way to go about it. So 6 minus 9i minus 10i plus 15i squared. So that would be minus 15 and 6 gives you minus 9 minus 19i, and they both have to be divided by 13. So then this would be your final answer. Alright. This one, the conjugate is just I. I know it looks like it's going to be negative I, but you know, it doesn't matter if you put negative I, it's still going to come out at the same time. Okay? Whether you multiply by negative I over negative I or positive I over positive I. Yeah, you just have to multiply by I to get rid of it. Okay? If you're multiplying by negative I, it's still going to work. If you want to see it both ways, go ahead and try it. I'm just looking to cut this short because I know sometimes these get a little long. I think that's the last page. Yep.